Hello, I am Ugochukwu Roland Tobogbo Jr., and I am here to present the capstone project for Data 670 titled Customer Sentiment Analysis Across E-commerce Platforms. So this project will explore customer sentiment on Amazon and Walmart using their product reviews. The objective will be to understand platform-specific behaviors and customer experiences. The analysis will include textual sentiment, star rating trends, and review engagement. The focus will be on identifying patterns, engagement length, and seasonal trends. Ultimately, I'll derive actionable insights through visualization and modeling. Unfortunately, the Walmart 2019 dataset was dropped due to lack thereof ratings or review text. The three datasets used are the Amazon Reviews dataset, the Walmart 2020 dataset, and the Combined Reviews dataset, comprised of information for both Walmart and Amazon reviews. Reprocessing included renaming columns, non-applicable filtering, and review date standardization using the as-POS6 function in R for time-based analysis. The unified dataset was created with 24,619 rows per platform in a wide format. Features engineering included adding review length to measure engagement. The wide format is retained for R visualizations, while a long format is developed in Python for modeling. R was used for visualization using functions such as ggplot2, dippler, lubridate, and word cloud. Python was used for modeling utilizing functions such as pandas, scikit-learn, and NLTK. Term frequency inverse document frequency was also utilized. Lemmatization and stop word removal all done in Python for the predictive models. The visualizations explore the platform patterns and engagement trends, while the predictive models focus on review sentiment and rating prediction. Combined, using R for visual storytelling and Python for predictive analysis will allow good data storytelling and modeling. The first visualization is a star rating distribution by platform bar plot between Amazon and Walmart. This compares star rating distribution between the platform reviews, normalizing review counts into percentages. As you can see, Amazon's reviews are heavily concentrated at 5 stars, while Walmart's reviews show a more balanced spread. These differences suggest platform-driven rating habits influenced by satisfaction levels or review moderation policies. Visualization. This visualization shifts the project scope to include normalization strategies. The next visualization is a bar chart of average review length by star rating. This visualizes how review length varies via star rating between Amazon and Walmart. The Walmart reviews are consistently longer than Amazon's across all star ratings, while the 2 and 3-star reviews are often longer than the highly positive 5-star ones, which suggests a slightly inverse relationship between the severity of how high the reviews are and the length of the reviews, with longer reviews from dissatisfied customers potentially offering rich feedback for customer business improvement strategies. These review lengths emerged as a valuable predictor, prompting feature scope reevaluation in the future modeling. As for the next one, this is a timeline series graph of review volume. This compares Amazon and Walmart monthly review volumes from 2015 to 2020. Amazon's shows sharp seasonal spikes while Walmart's growth is gradual with fewer dramatic peaks. This reveals that Amazon data skews earlier while Walmart offers broader, more consistent time coverage with the data that was available from the downloaded datasets. You can also see that seasonal patterns highlight platform differences and inform time-sensitive marketing and modeling strategies, with Walmart having high volume output for the holiday season and parts of the summer, suggesting the influence of Prime Day or the deals that they implement during Black Friday and near Christmas and Thanksgiving. Walmart shows a gradual increase from its more slowly implemented digital footprint. This scope expands for potential adjustments in time and seasonal predictors, with there not being as much data in terms of dates available for Amazon compared to the Walmart data. The final two visualizations are word clouds by platform, with Amazon being the warm colors and Walmart being the cool colors. These reveal platform-specific tone, emotional content, and review vocabulary differences. Amazon has emphasis on words such as great, tablet, and good, which signifies product quality and usage of electronics for this specific dataset. Walmart features money, love, pack, and terrible, which suggests a greater mix of praise and complaints, although for packaged deals. This sentiment variation exemplifies differences in customer interpretation of service. Stakeholders also benefit from intuitive visuals connecting emotional tone to business and modeling decisions. Whether they're the technical stakeholders, such as the project managers, the business analysts, or the non-technical ones, such as marketing analysts or sales representatives. As for the text preprocessing and feature engineering, as mentioned earlier, normalize the text. I utilize lowercasing, lemmatization, and stop word removal. For the feature creation, identified the review length as a potential feature. We also looked at potential sentiment scores and TF-IDF vectors. These process data sets were also split for training and testing models for the prediction. As for the predictive models used, one will be logistic regression, which is a baseline classifier using TF-IDF features. Random forest, which is an ensemble model effective for sparse features. And XGBoost, which utilizes boosted trees with regularization for potentially higher accuracy. As for the evaluation metrics of the champion model, we look at the accuracy, which measures overall correct predictions, which is useful for quick performance checks and can be misleading with class imbalance. As for the macro F1 score, the average F1 score across all star ratings balances position and recall for each class and best for imbalanced data sets. For the confusion matrix, it'll show the predicted versus actual values per class while highlighting where the model misclassifies and offers deep diagnostic insight. So this is the logistic regression model. As you can see, a confusion matrix was created with the bottom results comprising of the position, recall, and F1 score. The logistic regression was trained with term frequency, inverse document frequency features, and synthetic minority oversampling technique to balance the class distribution, as initially the 5-star reviews made up roughly 60% of the review output prior to creating the predictive models. The model best performs in predicting extreme ratings with lower accuracy with neutral classes like 3 and 4, while achieving a 64.2% accuracy and a 0.694 macro F1 score with the strongest F1 ratings for 1 and 5, which implies its heightened ability to predict extremities rather than more neutral ratings. Smote also improves the minority class recall, but introduces potential gaps in real world generalization due to creating synthetic reviews. The next model, random forest. The random forest ensemble model was trained using 90 trees and smote balanced TF-IDF features. This was effective in handling overfitting and non-linear relationships in high-dimensional review data. This also performed best on polarized classes such as 1 and 5-star reviews, while being weakest on 3-star predictions. The 3-star classification had low recall despite decent precision, showing semantic overlap issues. Overall, it achieved a 61.02% accuracy and 0.597 macro F1 score using Python's scikit-lean implementation. As for the last predictive model, we have XGBoost, which was trained on smote-balanced TF-IDF data, but unfortunately performed poorly in multi-classification. The model showed extreme bias for predicting 1-star reviews disproportionately across most of the true rating categories. It achieved only 22% accuracy and a 0.14 macro F1 score, which shows it underperformed compared to the simpler models. The four-star ratings received 0 correct predictions, which is very unusual, but also highlights serious generalization and learning issues. TF-IDF's sparsity and smote synthetic data likely destabilized XGBoost boosting mechanism, so it was very sensitive to the synthetic data that was introduced in order to reduce imbalance. XGBoost also requires advanced tuning and likely richer features for effective performance on text-based stacks. Due to the limitations on the available data, I was only able to use so much input variables in order to figure out how they affect the target variable. So as for comparing and contrasting the models and determining a champion model, it's pretty obvious that logistic regression outperformed the other models with a 64.2% accuracy and relatively balanced multi-class predictions. Random Forest showed medium success in comparison, but struggled as well with the neutral and mid-range star ratings while having a lower accuracy and lower macro F1 score. XGBoost surprisingly performed the worst, predicting mostly 1-star reviews with 22% accuracy and extreme bias. Logistic regression trained the fastest, offered the highest interpretability, and required minimal tuning or complexity. XGBoost's poor performance revealed incompatibility with the TF-IDF and smote augmented text data. The logistic regression's explainability and stability make it the strongest candidate for future deployment with some necessary tweakings. As for the justifications and findings, TF, IDF, and SMOTE were utilized to build and evaluate the 3 sentiment classification models, as high imbalance can influence bad predicting. But it also seems that introducing this synthetic data heavily affected the XGBoost predictive model. Logistic regression offered the relatively highest accuracy macro F1 score, speed, and transparency and clarity. Random Forest showed solid accuracy but struggled with mid-range sentiment and slow performance. Unfortunately, XGBoost underperformed with low accuracy, high runtime, with the runtime taking as long as 10 minutes, and poor class prediction balance. The exploratory data analysis insights on review length and word frequency helped shape the pre-processing and model decisions in order to create these predictive models. The logistic regression aligned best with business goals and fairness, efficiency, trust, and actionable insights. Although metric results have room for improvement, with the accuracy only being a 64% and the micro F1 score only being a 0.6394. As for lessons learned, maintaining wide and long formats helped with using both R and Python. Amazon review count dominated analysis, which required normalization via a long format. The word cloud shows high keyword variation across platforms that should be studied by stakeholders in order to determine any adjustments in user interface and assistance. Data wrangling was a bit more time consuming than expected, although logistic regression model only took about half a minute to generate, while the random forest model took about 4 minutes after some tweaking, and the XGBoost took the longest at close to 5 minutes. Text normalization is also crucial for both R and Python workflows. The review volume imbalance was handled via a long format when utilizing SMOTE to introduce synthetic data. Recommendations and conclusions. It's important to promote reviews with higher helpfulness and emotional clarity, such as the neutral reviews, which have high clarity compared to the more extreme reviews with more simple clarity. If someone likes something, they'll provide simple explanations as to why they don't like it. If they really like it, chances are they'll mention how good it is, how amazing it was, in maybe probably a sentence. But between the 2 and 4-star ratings, there's room for inspecting customer engagement, because those 2 to 4-star reviews are where customers will provide the most in-depth explanation for justifying what they rate that product. In terms of optimizing content strategy per platform is necessary for any topic modeling, such as encouraging customers to share more detailed feedback. It's also important to use sentiment trends to improve customer experience strategy. All right, that's the end. Thank you for watching. If you have any questions, you can comment down below, or as I'm presenting this to a group, you can ask questions afterwards.